Right now, at this exact moment, our entire galaxy is being dragged through space, not slowly, not gently. We're talking about the Milky Way, all 200 billion stars, every planet, every moon, every atom of you, hurtling through the cosmos at 2.2 million kilometers per hour. And the terrifying part? We have almost no idea what's pulling us. It sits in a region of space we literally cannot see. It warps the paths of thousands of galaxies at once. And it is so absurdly massive that scientists spent decades refusing to believe it was real. They call it the Great Attractor. And once you understand what it is, you will never look at the night sky the same way again. Welcome back. If you're new here, this channel is where the universe gets uncomfortably large, and we love every second of it. Today we're going deep on one of the most mysterious gravitational anomalies in all of cosmology. We're going to cover what the Great Attractor actually is, why it took scientists so long to even find it, what new discoveries have completely changed the picture, and what this whole thing means for the long-term fate of our galaxy. No math degree required, just buckle in, because this one goes places. Something is pulling everything. Let's start with the basics, because this story begins with a mystery that nobody was even looking for. It's the 1970s. Astronomers are mapping the movement of galaxies, just routine science, charting how things move through the universe. And they notice something strange. Galaxies aren't just moving away from each other the way you'd expect from the Big Bang. They're also drifting, all of them in the same general direction, like a river with a current underneath it. Our galaxy is part of that river. And so are our neighbors. Thousands of galaxies all being nudged, no, pulled, toward a single point in the sky. Here's an analogy that might help. Imagine you're on a massive trampoline with thousands of bowling balls scattered across it. If you put one enormous bowling ball somewhere on the trampoline, everything else rolls toward it. Doesn't matter where the other balls started. They all feel that pull. The Great Attractor is that enormous bowling ball, except instead of a trampoline, it's space-time itself. And instead of bowling balls, it's entire galaxies. The problem? When astronomers tried to look at where this gravitational pull was coming from, they hit a wall. Literally, a wall of stars. The center of the Milky Way sits right in that direction. And our galaxy is absolutely packed with gas, dust, and stars along that line of sight. It's called the zone of avoidance, a band across the sky where all that material blocks our view completely. We couldn't see the thing pulling us. For decades, we were driving towards something we couldn't even look at. What we found when we finally looked. So how do you study something you can't see? You look in wavelengths that can pierce through the dust. X-rays, radio waves, infrared light. These travel through the galactic haze like headlights through fog. And when scientists finally pointed those instruments toward the zone of avoidance, they found something staggering. An enormous supercluster of galaxies. Hundreds of thousands of galaxies, all bound together by gravity, forming a structure so large it defies easy comparison. This region, centered roughly 250 million light-years away, was dubbed the Norma Cluster at its core, sitting within a massive overdense region of the universe. 250 million light-years. That means the light we'd use to study it left before dinosaurs existed on Earth. We're looking back in time just to find the thing dragging us forward. But here's where the story gets even more interesting. For a long time, scientists thought the Great Attractor itself, that gravitational sweet spot, was the final answer. The Norma Cluster, massive as it is, explained the pull. And then, in 2016, a team of researchers released a discovery that completely rewrote the map. Using radio telescope data, they identified a previously unmapped supercluster of galaxies, one of the largest structures ever found in the observable universe. They named it Vela. It sits about 800 million light-years away, hiding almost entirely behind the zone of avoidance. And Vela alone may account for half of our total peculiar velocity, our unexpected movement through the cosmos. So we thought we'd found the thing pulling us, and then we found something even bigger behind it. The universe just keeps doing that to us. We are being swallowed by something incomprehensible. All right, here is where things get genuinely hard to hold in your head. Stay with me. The Great Attractor isn't just a cluster of galaxies. It's a gravitational focal point within something astronomers call Laniakea, a supercluster so large that visualizing it requires completely abandoning human intuition. Laniakea was formally defined in 2014 by Brent Tully and his team, and when they mapped it out, tracing all the gravitational flows, all the rivers of galaxy motion, the shape they found was almost biological, like a jellyfish, like a brain. Hundreds of millions of light years across, with long filaments of galaxies stretching outward and a dense core at the center. That core, that's where the Great Attractor is. And Laniakea, this entire cosmic jellyfish, is our home. The Milky Way is one tiny, unremarkable dot on one of its outer arms. Let that breathe. Now here is the part that should make your brain hurt. Even as everything within Laniakea is falling toward the Great Attractor, even as we're hurtling in at over 2 million kilometers per hour, we will almost certainly never arrive, because the universe itself is expanding. The space between us and the Great Attractor is stretching. Dark energy is pushing everything apart faster than gravity can pull it together. We are being pulled toward a destination that is simultaneously moving away from us. Think about that. Imagine running toward a finish line that stretches further away with every step you take. You're moving, you're working, but the gap never closes. That's us. That's the Milky Way, running toward the Great Attractor for billions of years and never getting there. And here's the final twist. Eventually, far in the future, the expansion of the universe will outpace even the Great Attractor's gravity. Laniakea will dissolve, the filaments will snap, the galaxies will drift apart until they can no longer feel each other's pull. The Great Attractor will lose, not because something defeated it, but because space itself will simply spread everything too thin. Why any of this should matter to you? You might be thinking, okay, fascinating, but this is all billions of years away. Why does it matter? And I'd push back on that. Hard. Because what the Great Attractor teaches us is something profound about our place in the universe. We like to think of Earth as the center of our story, and it is, for us, in the human sense. But cosmically, we are a single speck in a galaxy that is itself a single speck in a supercluster that is itself falling toward a gravitational anomaly we didn't even know existed until 50 years ago. There are forces shaping the destiny of everything we'll ever know, forces so vast and so distant that they were invisible to us until we invented the right instruments to see them. And there are almost certainly forces we still haven't found, hiding behind clouds of gas and dust and the limits of our technology. The Great Attractor is humbling. It is genuinely humbling. But it's also, and I mean this, wonderful, because it means the universe is so much richer, so much stranger, so much more deeply structured than a simple map of stars could ever show. There are rivers in space-time itself, currents we're all riding whether we know it or not. You are not just on Earth. You are not just in the solar system. You are in the Milky Way, which is in the Virgo Supercluster, which is in Laniakea, which is falling, right now, toward a point in the darkness 250 million light-years away. You are part of something ancient and enormous and almost entirely mysterious. And I think that's worth knowing. So, the Great Attractor. A gravitational anomaly we stumbled upon by accident, couldn't see for decades, and still don't fully understand. A pull so powerful it moves entire galaxy clusters, and yet so outmatched by the expansion of the universe that it will ultimately lose. The cosmos gives with one hand and takes with the other. If this video made you feel tiny and amazed at the same time, that's the point. Hit that like button if it did, because it genuinely helps this channel reach more curious people. And if you're new here and you want more of this, the kind of space content that actually changes how you see things, subscribe. We drop new videos every week. Next time, we're going somewhere even stranger. We're looking at the cosmic void, the largest empty regions in the observable universe, where entire galaxy clusters simply don't exist. What are they? Why are they there? And is it possible we're already inside one? That one's coming soon. Don't miss it. See you in the dark.